Hi guys and welcome to Magic. As you can see, I have just now recently released version 9.1.7 of Magic Cloud, and it contains actually only one interesting feature, but actually that's a very interesting feature. And it's a bit difficult to explain, so I'm going to be writing a DSON article about the concept. Which might be the place you are actually watching this video from. However, it doesn't matter. Let me illustrate it. So we've always had the crypto menu item here, right? And this, of course, being my server's public key, this being its fingerprint, etc., some information, and these being the public keys I have imported into my cryptography key database table. However, there is one crucial extra little text box here, and that is username. And it might not look like much, but the internals of that little text box is actually extremely interesting. Why? Because it allows me to do something I don't think I've ever seen before in my entire life, which probably is most accurately described as asymmetric authentication. And it is based upon a cryptography challenge. You see, if I now go to my endpoints here and I filter for challenge, you will see that there are two new endpoints here. One get and one post. Now the get challenge actually just returns gibberish, right? That's all it does. And this gibberish is valid on the server for 5 minutes. However, what I'm expected to do is that I'm expected to take this gibberish and cryptographically sign it with my own client's private key, submit the signed gibberish back to the server, at which point the server will extract the public key for the private key used to sign the payload, verify the signature, and do an association up towards the user's database table, allowing me to actually use this one after I have cryptographically signed it and invoke it, and having returned a JWT token, effectively authenticating me as a client towards the server that actually served the challenge in the first place. Let me illustrate it showing some hyperlambda, because I have created a new hyperlambda snippet. If you click load and you filter for crypto, you'll find authentication challenge. Here you see I'm invoking the get challenge endpoint, which returns gibberish, right? Random gibberish. Gibberish is valid for 5 minutes. Then I load my server's public key. The only reasons why I'm doing that is because I need a fingerprint and supply it to the crypto.sign invocation further down here. Then I load the private key, and then I use my private key to sign the result of the invocation to the get challenge thing. At which point I'm given a cryptographically signed base 64 encoded array of bytes. Then I supply that again to the HTTP post endpoint, which has the exact same URL except it's the post word. I pass in my cryptographically signed gibberish as JSON with the name of payload being the field. And then when I come down here at the end of the file, I end up with a JWT token. Let's execute it just to have a look at it. It's deadly fast, by the way. And why didn't that work? Set value. Let's try again. Result. There is something wrong here, so let me see what that actually is. Lambda to JSON, HTTP post, JSON to Lambda, result. Yeah, here we go. Sorry. Here is my JWT token. And actually I can confirm it by going to jwt.io and I can paste in the token here, which point I see, okay, username root belonging to the role of root. So I authenticated as a user on the server without having to provide a password, without having to provide even a username, without having to provide anything at all. And the way I did it was by requesting a challenge, a cryptographic challenge. Then I cryptographically signed that challenge. And then I submitted that challenge back to the server, cryptographically signed. Server returns a JWT token to me back as a result. So 2 HTTP requests, first getting a challenge, then getting that back to the client, cryptographically signing it, posting the cryptographically signed challenge back to the server within 5 minutes, of course, before it expires. And boom, I'm authenticated. 0 password authentication. And paradoxically, this is actually probably even more secure than actually typing your password. Now, there are some challenges related to this. For instance, it doesn't really play well with things such as browsers, right? Because you need to have your private key stored somewhere. And I think ProtoMail has some solutions to it. But I mean, at the end of the day, you probably end up having to storing it in your local storage or something like that, which is probably suboptimal. However, if you're on a thick client, such as, for instance, iOS or Android or for that matter, Windows app, then it's much easier for you to actually secure a private key and request a challenge and cryptographically sign that challenge with your private key, then submitting the cryptographically signed challenge back to the server, at which point the server actually authenticates you and returns back a valid JWT token that you can use for consecutive HTTP requests towards the server, at which point you're actually authenticated as that particular user. So for thick clients, iOS, iPhone apps, Android apps, etc., this is probably like orders of magnitudes more secure than actually asking the end user to provide this password. And it's asymmetric in nature, implying the server actually never, ever, ever knows your password. So not even the server have, not even in theory, the capacity to actually impersonate you. And it's all based upon one simple idea, which is that the public key here is associated with a username. And that's it, really. And of course, you can associate any number of public keys with the same user. But you can only associate one public key with one user, obviously, because, I mean, it's a one-to-many relationship here. And the way it works is that it uses one-to-many table here. If I go here, select all from, and then I find users crypto keys here, you will see here that the username of root is associated with the key having an ID of 16. If we now select from crypto keys, oops, then you will see that the key with the ID of 16 is this particular key with this email. Right, and here is its content. So it's asymmetric authentication where the server exclusively has access to your actual public key and never ever have access even to your private key, making it not even possible in theory for the server to actually impersonate you, arguably, you might say. So anyway, it's a bit experimental, this feature, I must confess. So be a bit careful with it. And also, I still haven't tested it on SQL Server. If you find any weird bugs, please let me know. And of course, I will attend to them. However, anyways, if you want to try out the asymmetric authentication or cryptography challenges as an alternative to username and password authentication, there's a link in the description to where you can download Magic and play around with it. Thanks for watching. Have a nice day.